after you read this question. Very first thing you're going to do. Amen. So I need to draw a triangle. I'm going to be purposely annoying, okay? So what do you guys think about my triangle?
It's not proportional.
It's what?
Wrong.
Well, isn't that wrong?
Well,
Draw
it's not wrong,
36
but it's not in the right quadrant or circle.
Ah, so you're saying it might be helpful if I actually think about the quadrants up front too. Now I could use this triangle and then think about quadrants afterwards. Or since it says it's in quadrant 4, I might as well take care of that now. There's my circle. And I'm going to go ahead and put my axes on there. And I need to draw a triangle. And I need it to appear in quadrant 4. So I'm going to go ahead, and we have to be careful. We always draw triangles in the same way. The radius goes out to the edge of the circle, right? And then we drop it straight to the x-axis. Now, sometimes it's a drop, sometimes it's a move up. But this is the convention for how we're looking at trigonometry inside of, and that's not perfect, I'm sorry, inside of the circle, right? This is how we extend trigonometry beyond right triangles and into circles and all angles. So now I've got my angle, like, theta right there. It's in quadrant 4, which is great. It got me that triangle. So what do I know about said triangle? The -4 is down. How do you know that?
Because sine is pretty much height, and now that's negative. Down 4 minutes.
Okay, so you're saying we kind of knew it was height, and so that's where the negative is.
Or opposite.
Or opposite. Yeah, and so that's what I'm going to use, is that -4/5 is really the sine ratio. So it is the opposite over the hypotenuse. And so I'm just going to go ahead and label my sides. Now, I choose not to put my negatives on because I can see them. And it helps me because I know some students put the negatives and then they try to use negatives inside of the Pythagorean theorem and they type them in the calculator wrong and it just doesn't work out. So I don't throw negatives on until the very, very end. It's just a choice. And by drawing it in the circle like Jasmine suggested, we're all set. We can see what's negative and what's positive. We just have to think a little bit about it. John?
Well, if you can see that one side is 4 and the hypotenuse is 5, you can reason out that the third side would be 3. Isn't that a perfect triangle?
3, 4, 5 right triangles. Yeah, so this is one of those Pythagorean triples. That's what they call them. The nice whole number sides. If I didn't know that, I could always use the Pythagorean theorem. No big deal. We've been doing that since what, 6th grade? Maybe 7th grade at the latest. So we can get that third side is 3. What questions do we have at this point? Notice, I honestly haven't even thought about what I was trying to find at this point in time. I'm spending tons of time thinking about what do I know and what does it look like. Because if I can see it, I can answer any questions I want now about that spot. I can find the angle for us. I can find out the trig ratios. But if I can't see it, I'm going to struggle. So, bottom line though, I am looking for tangent of theta, which I know is opposite over adjacent. But I also know that my opposite side was really going downward, so that was a negative. And I know my adjacent side is not going backward, it's going forward, so that is a positive. And so I know that the tangent ratio is -4/3.